In this exercise, we are going to find the critical value associated with a left-tailed test when testing a claim about a mean where sigma is unknown. A simple random sample of 1,862 births of Chinese babies resulted in a mean birth weight of 3,171 grams and a standard deviation of 428 grams. Use a 0.01 significance level to test the claim that the mean birth weight of Chinese babies is less than the mean birth weight of 3,369 grams for Caucasian babies. We began by finding the claim. The claim here stated that the mean weight is less than 3,369 grams. This allowed us to establish our null and alternative hypotheses. Our null hypothesis being the equality case and our alternative hypothesis being the less than case. Since we see the idea of less than coming up here, this is what tells us that we are going to be using a left-tailed test. Now, additionally, in this problem, nowhere are we given sigma, which is the standard deviation of the population. The standard deviation that we're given here of 428 grams comes from our simple random sample. This is actually our value of S, not a value of sigma. So because of this, we want to make sure that we are going to use the student T distribution. And thus our critical value will be a T-score for this problem, not a Z-score. Looking graphically, because it is left-tailed, we're going to want to find a critical value that appears on the left-hand side, thus a negative value. Now, when we are looking at this, we want to make sure to use the proper degrees of freedom. Our sample, though, has 1,862 in it. This is quite a large amount. So we are okay to use our degrees of freedom if we're using our chart to be 1,000 in order to work this through here. Now, if you're using your technology, either TI-83 or 84 graphing calculator, please refer to the graphing calculator videos that we have posted as well. For our degrees of freedom here, we want to find the area in one tail to be 0.01. And the reason why is because we have a 0.01 significance level. This is our alpha value. So our alpha equals 0.01 should represent that area in the left tail. From our chart, we can see that the T value that comes to is going to be 2.328. However, since we are looking at the left-hand side and doing a left-tailed test, we must remember that this value should be negative. Thus, the critical value that is associated here is going to be T equals negative 2.328. In this problem, we found the critical value that was associated with a left-tailed test when given a claim about a mean where sigma is unknown.